Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss surface areas and volumes. In this chapter, in the previous class, we have discussed the concepts of exercise 13.2. In that exercise, we have discussed the curved surface area of a right circular cylinder and total surface area of a right circular cylinder. And we have discussed some questions related to curved surface area of a cylinder and the total surface area of a cylinder. I hope you have understood that concepts well, and I hope you have learned the problems related to a right circular cylinder. Haven't you, my children? Right. Now come to the exercise 13.3 concepts. Are you ready to listen the class? Right. In this exercise, we mainly focus on surface area of a right circular cone. Okay, my children. Let us define what is meant by a right circular cone. After that, we find the formula to find the surface area of a right circular cone. Okay, my children. Right. So far, we have been generating solids by taking up congruent figures. Yes or no, my children? In the case of cubes and in the case of cuboids and in the case of right circular cylinders, we have used identical figures, congruent figures. Incidentally, such figures are called prisms. Do you remember the definition of prisms, my children? In the earlier class, you have studied different kinds of solids and their names, prisms. Yes or no, my children? Right. Now, let us look at another kind of solid which is not a prism. These kinds of solids are called pyramids. This is also learned in the earlier class. Haven't you, my children? Prisms and pyramids. You have studied, you have learned in your earlier class. Yes or no, my children? Right. Now let us see how we can generate them. Okay, my children, how to generate pyramids which are not prisms. Okay, my children. Now let us do this activity. Cut out a right angled triangle ABC, right angled at B. Okay, my children. Let us take a piece of paper and cut that piece of paper into a right angled triangle, and right angled is at B. Okay, my children. Paste a long thick string along one of the perpendicular sides of the triangle ABC. Say AB of the triangle. See the figure 13.13a. We see this figure in the next slide. Okay, my children. Hold the string with your hands on either sides of the triangle and rotate the triangle about the string a number of times. What happens? Do you observe, my children? Do you recognize the shape that the triangle is forming as it rotates around the string? See the figure 13.13b. This figure is also shown in the next slide. Okay, my children. Does it remind you of the time you had eaten an ice cream heaped into a container of that shape? See that figure 13.13c and d. Okay, my children. In the next slide, we see these figures. Okay, my children. Right. So we have rotated. Okay, my children. Then get a solid shape. This resembles a cone. Okay, my children. This is called a right circular cone. In the figure 13.13c, see this figure. This is the figure 13.13c of right circular cone. The point capital letter A is called vertex. Here this is capital letter A. Here, okay, my children. AB is called the height. Here this is the height of the right circular cone, and BC is called radius. This line segment BC is called radius, and AC is called the slant height of the cone. This is slant height of the cone. These are the dimensions of a right circular cone. What are the dimensions of a right circular cone? Yes, height of the right circular cone radius of the right circular cone and slant height of a right circular cone. Okay, my children, understood this point? Remember these points, my children. Here, capital letter B will be the center of circular base of the cone. Observe this figure, my children. Here B is the center of this right circular base of the cone. The height, radius and the slant height of the cone are usually denoted by H, R and L respectively. Okay, my children, we use these three letters to denote height, radius and the slant height of a right circular cone. Okay, my children, right. Once again, let us see what kind of cone we cannot call a right circular cone. Okay, my children, here you are, see that figure 13.14, see this figure, my children. What you see in these figures are not right circular cones, because in 1A, this figure, the line joining its vertex to the center of its base is not at right angle to the base, and in figure B, the base is not circular. Okay, so these are also cone, but these are not said to be a right circular cone, because here the height of this, the line segment joining the vertex of the cone and center of the circle is not perpendicular to the base, and in this case here base is not in the shape of a circle. That is why these two cones are not said to be right circular cone. Okay, my dear children, understood this difference, which is said to be a right circular cone and which is not said to be a right circular cone. Yes, and in the case of cylinder, since we will be studying only about right circular cones, remember that cone in this chapter we shall mean a right circle cone. Okay, my children, in this chapter cone means we have to understand we should mean a right circular cone only. Okay, my children, right. Now let us do this second activity to find the surface area of a right circular cone. Okay, my children, cut out a neatly made paper cone that does not have any overlapped paper. Okay, my children, straight along its side and opening it out. Okay, my children, we have opened this one cone to see the shape of paper that forms the surface area of the cone. If you open this cone, after cutting this cone, after opening that cone, we get this kind of piece of paper. Yes, the line along which you cut the cone is the slant height. This is nothing but slant height of the cone, which is represented by L. Okay, this is L. This is a slant height of the cone. It looks like a part of a round cake. Yes, this looks like a part of a round cake. Yes, right. If you now bring the sides marked A and B at the tips together, see this figure, my children, you can see that the curved portion of figure 13.15C, see, observe this figure, my children, will form a circular base of the cone. Yes, my children, this is the circular base of the cone. Now, if the paper like the one in figure 13.15C is now cut into hundreds of little pieces along the lines drawn from the point O, each cut portion is almost a small triangle. So if you cut this figure into a small pieces, then they form a small triangle. Number of small triangles whose height is the slant height L of the cone. Yes, right. Then area of each triangle is equal to half into base into height. Yes, half into base of each triangle into height, means height of the triangle is L. Understood this point, my children? Right. So area of the entire piece of paper is equal to sum of the areas of all the triangles. Yes or no, mention? Right. That is equal to 1 by 2 into B1 into L plus 1 by 2 into B2 into L plus 1 by 2 into B3 into L plus and so on. Yes or no, mention? By adding the areas of all these triangles, we get the area of the entire piece of the paper. Yes or no, mention? That is equal to 1 by 2 into L. If you take the common factor from all these terms, 1 by 2L is a common factor. As I mentioned, so 1 by 2 into L of B1 plus B2 plus B3 and so on. Understood this step, my children? Right. That is equal to 1 by 2 into L into, what does this denote? B1 plus B2 plus B3 and so on. This is nothing but length of entire curved boundary of figure 13.15c. Yes or no, my children? The sum of all these lengths equal to the length of entire curved boundary. Yes or no, my children? As B1 plus B2 plus B3 and so on makes up the curved portion of the figure. Understood this point, my children? But the curved portion of the figure makes up the perimeter of the base of the cone, and the circumference of the base of the cone is equal to 2 pi r. Yes or no, mentioned? This is the formula to find circumference of the base of the cone, 2 pi r, where r is the radius of the cone. Yes or no, mentioned? Right. Therefore, curved surface area of a cone is equal to half into L into, here this length of entire curved boundary is nothing but 2 pi r, circumference of the base of the circular cone. That is equal to, by simplifying these two numbers, what will get here? 2 gets cancelled. Here 2 gets cancelled. Then what will get after simplification? Yes, pi rl. Please remember this formula, my dear children, to find curved surface area of a cone is equal to pi rl, where r is the base of the radius and l is its slant height. Understood this point, my dear children? Right. In the previous slide, we have discussed the curved surface area of the cone. In this slide, we are going to discuss total surface area of a cone. Okay, my dear children? Right. Note that L square is equal to R square plus H square, because this is a right angle triangle. By using the Pythagoras theorem, side square plus side square is equal to hypotenuse square. Yes or no, my children? So L square is the hypotenuse. As it can be seen from the figure 13.16, by applying Pythagoras theorem, here H is the height of the cone. Yes or no, my children? Therefore, L is equal to, from this equation we get square root of R square plus H square. Remember this relation between L, R and H, my children, of a cone. Now, if the base of the cone is to be closed, then the circular piece of the paper of radius R is also required, whose area is pi r square. If you want to find the total surface area of this cone, we have to add the area of this circular base. As I mentioned, so curved surface area of the cone plus area of the base of the cone. Then we get total surface area of the cone is equal to pi rl. This is nothing but curved surface area of the right circular cone plus pi r square. This is nothing but area of the base of the right circular cone. Understood these two terms, my children? Right. From these two terms, if you observe, pi r is a common factor. Yes or no, my children? Right. Now let us take the common factor pi r. Then we get pi r into L plus R. Please remember this formula, my children, well. Memorize this formula well to find total surface area of a cone. Okay, my children, understood this point? Right. To understand these concepts well, let us take an example. See the example. Find the curved surface area of a right circular cone whose slant height is 10 centimeters and base radius is 7 centimeters. Understood this question, my children? Right. The slant height and the radius of the base of a right circular cone is given. Then we have to find the curved surface area of the right circular cone. Now come to the solution part. What is the formula to find curved surface area of a right circular cone? Yes, pi r L. Do you remember this formula, my children? Right. That is equal to, previously we have discussed, pi means 22/7. This is an approximate value, not exact value. Don't be confused here, my children. Only for our convenience, for easier calculation, we are taking pi value is 22/7. Not, it is not exact value. Okay, my children. Into what is the radius of the cone? 7. Into what is the slant height of the cone? 10 centimeter square. Understood this step, my children? Right. Now by simplifying these numbers, here 7 gets cancelled. Yes or no, my children? Then what will you get here? 22 into 10. What is the value of 22 into 10? Yes, 220 centimeters square. Understood this solution, my children? Right. Now let us take another example to understand these concepts well. Okay, my children. See this example. The height of a cone is 16 centimeters and its base radius is 12 centimeters. Find the curved surface area and total surface area of the cone. Use pi is equal to 3.14. Understood this question, my children? What are given here? Height of the cone and radius of the base of the right circular cone. These were given. Then we have to find curved surface area and the total surface area of the cone. Okay, my children? Right. Now come to the solution part. Here h is equal to 16 centimeters. H denotes height of the cone and r is equal to 12 centimeters. R denotes radius of the cone. Yes or no, my children? Right. So we know this relation between L, H and R. L square is equal to H square plus R square. Okay, my children? Right. So from this relation, we have to find the value of L. Because to find the curved surface area of a cone, what is the formula? Pi r L. Yes or no, my children? That is why we are finding the value of L. So L is equal to square root of, in this formula we substitute H square. H means here 16 square plus 12 square. Understood this step, my children? That is equal to, by simplifying these two numbers, what we get finally? 20 centimeters. This is the value of L. Here we found slant height of the cone. Understood this step, my children? Right. Now come to the curved surface area of the cone. That is equal to pi r L. Do you remember this formula, my children? Yes. So curved surface area is equal to pi r L. That is equal to, here we should take pi is equal to 3.14. So 3.14 into r is equal to 12 into what is L value here? We have found 20 centimeters square, because this is the units of the area of the cone. Okay, my children? Understood this step? Right. That is equal to, by simplifying, by multiplying these three numbers, you get 753.6 centimeters square. Understood this step, my children? Right. And moreover, we have to find total surface area of the cone. What is the formula? Pi r L plus pi r square. Yes or no, my children? Do you remember this formula? Right. That is equal to, what is here? Pi r L we have already found 753.6 plus pi means here 3.14 into what is all here? 12. So 12 into 12 centimeters square. Understood this step, my children? Right. That is equal to 753.6 plus, by multiplying these three numbers, what will you get? 452.16 centimeters square. Understood this step, my children? Right. By adding these two numbers, what will you get here? 1205.76 centimeters square. Understood the solution of this example, my children? Right. Now let us take another example. Okay, my children. A cone cob, see that figure 13.17, see this figure, my children? Shaped somewhat like a cone. It looks like a cone. Has the radius of its broadest end as 2.1 centimeter and length that is height as 20 centimeters. So what are given here? Radius of the cone and height of the cone were given. Yes or no, my children? If each 1 centimeter square of the surface area of the cob carries an average of 4 grains, find how many grains you would find on the entire cob. Understood this question, my children? We have to find number of grains you find on this corn cob. Okay, my children? Means we have to find curved surface area of this cone. Yes, my children? Right. Now come to the solution part. Since the grains of the cone are found only on the curved surface area of the corn cob, we would need to know the curved surface area of the corn cob to find the total number of grains on it. Yes or no, my children? Got this point? Yes. In this question, we are given that height of the cone, so we need to find its slant height. Yes or no, my children? To find the curved surface area of the cone, what are the values needed? L and R. Yes or no, my children? So we are finding L. So L is equal to square root of R square plus H square. Do you remember this formula, my children? Right. In this formula, let us substitute R and H values. Okay, my children, that is equal to square root of, what is R here? 2.1 whole square plus what is H here? 20 whole square centimeters. Understood this step, my children? Right. That is equal to square root of, by adding these two values, what will you get? 404.41 centimeters. Okay, my children. Now we have to find the square root of this number. Then what is the value of square root of this? 104.41? Yes, 20.11 centimeters. By division, by long division method, we have to find the square root of this number. Do you remember that long division method to find square root of a number, my children? Yes, by using that method, we have to find square root of this number. Then we get 20.11 centimeters. This is the slant height of the corn cob. Okay, my children? Right. Therefore, the curved surface area of the corn cob is equal to pi RL. Yes, sir, my children, this is the formula to find curved surface area of the corn cob. That is equal to here, pi is equal to 22/7 into what is our value here? 2.1 into what is L value? We have found 2.11 centimeters square. Understood this step, my children? Right. That is equal to, by simplifying these three numbers, what will you get? 132.726 centimeters square. Understood this number, my children? Right. Let us write the approximate value of this number. So 132.73 only, because here 6 is there. So we add 1 to this previous digit. So we wrote 132.73 centimeters square approximately. Understood this number, my children? Right. Now come to number of grains of corn on 1 centimeter square of surface area of the corn cob is equal to 4. It is given in the question itself. Okay, my children. Therefore, number of grains on entire curved surface of the cob is equal to 132.73 into 4. Yes or no, my children? Understood this step? Right. That is equal to, by multiplying these two numbers, what will you get here? 530.92. Yes or no, my children? So here also we have to find approximate value of this number. That is equal to 531. So 531 grains will be there on the entire corn cob. So there would be approximately 531 grains of corn on the cob. Understood this solution of this example, my children? Right.